session, we will be comparing data sets, which means that we'll be looking at one set of data using multiple representations, so dot plots, histograms, and box plots, to see what the different representations can tell us about that data. But we will also be looking at how two sets of data can be compared. Now, to compare two sets of data, what we're going to use is we're going to use our median, our mean, our range, and our interquartile range. So these are all key features of our graph that we have already learnt how to find. So you'll need to be using those tools that you have in this section. How they group together is that we have our median grouped up with our interquartile range. The reason is that these won't be affected unless the middle section of our data is affected. And our range and our mean will be grouped together. So we'll be comparing those in two separate pairs. So let's look at an example of how to do this. You can find this on page 342 of your textbook. You can see that set A and set B are quite similar. In fact, they are nearly identical apart from this one number here. In set A it's a 9, but in set B it's changed to a 19. So as we've just talked about, and you can see, the median and the interquartile range should not be affected by this, as they only deal with the middle spread of scores in the set. Whereas this will change dramatically our range, and it will also change our mean. So these are the four things that we're going to find. You can see in parts A, B, C, and D, and then we're just going to compare them. So as we go about calculating our mean, our median, and our range, you know how to do this already, so we won't be spending time on that now. But you can see how the mean has been affected. Set B has a larger cumulative frequency, and so its mean is greater. The median has not changed, but you can see the range has changed dramatically. Turning over the page, we have the interquartile range unchanged as well. It is identical for both data sets, and you can have a read of what kind of comparisons we can make here on page 343. Now that we've also learned how to make box plots, we can look now at doing parallel box plots. Parallel box plots is where we draw a box plot for each set of data, but on the same axes, so we can see exactly how they change and differ from each other. So in this worked example, we're looking at heights of students from two different Year 8 classes. We're going to be finding the median height, the range, the interquartile range. That's going to help us draw our box plots, and then we can compare our data. So turning over the page, you can see our median was 156. Our range differed. It was 20 in class 8A and 13 in class 8B. And you can see that here we have our lower quartile, our upper quartile, and we use those to work out our interquartile range. The same goes for set B. When we come to put our parallel box plots together, you'll notice that's the same scale that's being used. So this is really neat. We can see one box plot on top of the other. We can see that the median is exactly the same. So 50% of students are underneath this height, and 50% of students are above this height. That is for both sets of data, but you can see that the first 25% in class AA are really spread out here, and the next 25% are grouped together. So the interquartile range is much smaller. There's a smaller group of students in the interquartile range, in the middle 50%, compared with 8B, where there's a lot more students with a similar height. And you can see that even our extremes are a lot closer together here. We don't have as much of a spread as our data, and this is what our parallel box plots can help us see. So now we're going to look at comparing different data representations. So we're using the heights of the 2011 playing list at the Melbourne Storm. Turning the page over to 345. So you can see that we're going to be, this is our data up the top here, and we're going to be using different graphs to compare our data and see what that tells us. We've got a histogram here. You can see the intervals that we're using are just in groupings of 2. We can work out our interval size by firstly working out our range and then seeing what would be a fair amount to put our interval size. We don't mind having 9 different interval classes. If we were going to go down any further and bump our interval class up to 3, then that would only give us 6 intervals. So having 9 is probably a good set to have, and we can see here that there are a lot of players towards the tall end. Not many very, very tall players, but there are certainly more players at the tall end of the scale here. Okay, we can use our CAS calculators to do our 5 numbers summary, and we can show you how to do that using the stat section. You'd need to type each individual height into a list and spreadsheet in your CAS, but now that we've got our minimum value, our first quartile, our median value, our third quartile, our maximum value, we can plot those up on a box plot. So right now you can see the median is pushed over further to the edge of our box plot, which does correlate with our histogram and also with our dot plot that we can see here. We can see a shift, a trend that there is taller players at the Melbourne Storm, and that's what we'll read about down here. Both the histogram and the dot plot show that there are more values at the right hand end of the range as opposed to the left hand end. In some cases where the range is quite big, the dot plot would also need to show grouped values. So that's saying if we have a lot of scores, we might need to put in some intervals into our dot plot. And now we're getting straight into some comparing dataset questions. So remember, you'll need to find the mean, median range and interquartile range of each of these sets of data. You'll need to be familiar with drawing box plots, dot plots, and histograms. So have a practice of those if you're feeling unsure about them. And really analyze the data. What is it telling you? So you'll need to look at the question. Is it about height? Is it about weight? Is it about scores for tests? You'll need to analyze the data in light of what the data is representing. This is the end of our session on comparing data sets.